All right, question 21. Yes, it's hard. So I'm going to start out by drawing the three triangles we actually have separately. So to start off, I've got ADB, ADB. This bottom line is X, and this angle is beta. I've got BDC, which would be great if I could draw. So this is a right angle, BDC. This is angle alpha. And this line would actually be y take x if you have a look at the diagram. And then my final one is the whole lot together, ADC. So this is a right angle, this is angle beta, and this is y, this is h, this is h. And this angle here would be 180 take alpha. This angle here, 90 take alpha. This angle here, 90 take beta. This angle here, 180 take alpha, take beta. I'm going to do this in a thinner pencil. So it's alpha take beta. Okay. This one we've got has x in it. So I can only assume I'm going to have to use the sine rule for x first. So x on sine alpha take beta equals, well, I don't know BD, but it's the same here. There's no point doing AD. Well, I could have done AD, I guess. I'm kind of just playing with it until I find things that I know. BD over sine beta, or if I'd wanted to do AD, because this is AD and this would also be AD, that would be AD over sine 180 take alpha. So I've got x, ooh, actually, no, because I want h. I've got h here, and h is here, but h is also here. I think the first and last ones I'm going to go with. So x on sine alpha take beta equals AD, yeah, this one. Okay. And I also know that from this triangle on the right, I've got sine beta equals h over the length AD. So AD equals h on sine beta. Okay, so I've got x on sine alpha take beta equals AD, which is h on sine beta, over sine 180 take alpha. So I've got x on sine, x sine 180 take alpha over sine alpha take beta. That's the worst alpha. Equals, now I've just got this top line, so I can just write it as a normal fraction. Okay, so now I can be like h, so now I can take that sine beta to the other side, so I've got x times sine 180 take alpha times sine beta all over sine alpha take beta equals h. Is that what they wanted? Sine alpha sine beta. Or in the middle triangle, I also have, if I want just sine alpha, the only spot that happens is in the middle triangle. So from the middle triangle, I have sine alpha equals h on BD. Okay. Which means BD equals h on sine alpha. Okay. So I've got x on sine alpha take beta equals BD, which was h on sine alpha, on sine beta. I'm going to take that sine beta up first. So I've got x times sine beta over sine alpha take beta equals h on sine alpha, which means I just need to rearrange this, and I get h equals x times sine alpha times sine beta over sine alpha take beta. So that's the kind of question you don't know how you're going to get there. You just start writing things and have a go. Okay, let me copy this one. And these are both h's. Okay, so I've got, from the question above, I've got h equals x sine alpha sine beta over sine alpha take beta. And if I've got tan alpha equals h on y take x, then h equals y take x tan alpha. Same with tan beta equals h on y, then h equals y tan beta. Oh, actually, I'm going to rearrange this for y because I've got a y in here that I don't want. So y equals h on tan beta. So I've got h equals h on tan beta take x times tan alpha. Maybe I don't need this one at all. This one at all. Okay, which means I've got h equals h times tan alpha on tan beta take x tan alpha. Get all the h's to the left, so I've got h minus h times tan alpha on tan beta equals negative x tan alpha. Take the h's out the front. I've got 1 minus tan alpha on tan beta equals negative x tan alpha. This is the same as tan beta on tan beta minus tan alpha on tan beta negative x tan alpha, which means I've got tan beta minus tan alpha on tan beta equals minus x tan alpha. Now I'm going to divide by that. So h equals negative x tan alpha divided by tan beta minus tan alpha on tan beta, which is negative x tan alpha times tan beta on tan beta minus tan alpha, which gives me negative x tan alpha tan beta over tan beta minus tan alpha, but they don't want the minus, so that's the same as negative x tan alpha tan beta over negative tan, if you take the negative out the front, you just swap them around, alpha minus tan beta, those negatives cancel out, I get x tan alpha tan beta over tan alpha minus tan beta. So that was h equals every time. It's that easy. Oh my gosh, how ridiculous. Okay, so the expressions we had were this thing, sorry, and we had this thing, so I can only imagine we make them equal each other. So I can only imagine we have x sine alpha sine beta over sine alpha take beta equals x tan alpha tan beta over tan alpha take tan beta. The x's disappear because they appear both sides. We're assuming x does not equal 0. Okay, so I'm assuming we're just rearranging this a lot. That may be easier said than done. Let's get everything onto one line. So I'm going to take the bottom here to the top, bottom here to the top. So I've got sine alpha sine beta times tan alpha minus tan beta equals tan alpha tan beta times sine alpha take beta. Okay. I'm going to now... Ooh. No. Yes, actually. See how this is on its own? Well, this is now on the top line, and it's on its own. So I want to get... Well, I can make it on its own if I get rid of that tan alpha, tan beta. So I'm going to have this stuff. Divided by that one. Tan alpha, tan beta. I don't need these brackets, by the way. Equals this thing. So that means this thing, equals this thing. And I think we're going to have to get rid of some stuff by using the fact that sine A over cos A equals tan A. So we're going to turn all these tans into sines and coses. So we've got sine alpha take beta equals, well, I've got sine alpha times sine beta times sine alpha on cos alpha minus sine beta on cos beta divided by tan alpha tan beta. So that gives me, I'm not going to expand this yet, that divided by sine alpha on cos alpha sine beta on cos beta. And now, instead of timesing, I'm going to dividing, I'm going to keep flip change. Smooth. So I'm going to turn these ones upside down. Cos alpha on sine alpha cos beta on sine beta. Now that everything's timed, so I don't actually need these brackets anymore. Can I cancel anything out? Yes. This sine alpha and this sine alpha, this sine beta and this sine beta. So I get sine alpha take beta equals cos alpha cos beta times this thing, sine alpha on cos alpha minus sine beta on cos beta. Is that what it's looking like? Okay, I'm going to have to simplify some more. So I'm going to expand these brackets. So that's going to give me cos alpha cos beta sine alpha on cos alpha minus cos alpha cos beta sine beta on cos beta. Both these bottom lines, they're going to cancel out. Cos alpha, cos beta, cos beta. So it's going to give me cos beta sine alpha minus cos alpha sine beta. And that was sine alpha minus beta. So please let that be what I wanted. I'm so over this. Sine alpha cos beta. Yes! Boom. Is that all of that question? D. Hence find the exact value of sine 15. Right. Okay. You may think that's irrelevant, but the angles I know to do with are 60, 45, and 30, yeah? So if I do alpha equals 45 and beta equals 30, then sine alpha is sine 45, which is 1 on root 2. Cos alpha, cos 45, which is 1 on root 2. Sine beta is sine 30, which is 1 on 2. Cos beta equals cos 30, root 3 on 2. Yes. Which means sine of 45 minus 30 equals cos 30 times sine 45 minus cos 45 times sine 30. Cos 30 was root 3 on 2. Sine 45, 1 on root 2, minus cos 45, 1 on root 2, sine 30, 1 on 2. So that gives me root 3 on 2 root 2 minus 1 on 2 root 2. So it's root 3 minus 1 on 2 root 2. Going to rationalise just as a flex. So that gives me root 2 times root 3 minus 1 over 2 times 2. So that gives me root 6 minus root 2 over 4. So that's sine 15. I'm going to chuck it in my calculator and see if we're right. So in the calculator, sine 15, 0.2588. And if I put this thing, root 6 minus root 2 over 4, 0.2588. Boom! Yay! Okay. Cool.